This time we're going to calculate the wave speed using a second equation. Wave speed equals the frequency times the wavelength, or in symbols, v equals to f times lambda. We start by first measuring the wavelength lambda, but it is difficult to measure while the waves are moving. So I'm going to use my magical powers and pause the video now. Once it is still, it is very easy to see where the troughs of the waves are, which are the positions of the bright spots. The wavelength of the wave is therefore given by the distance between the bright spots. To be more accurate with our measurements, we are going to measure 10 wavelengths between here and here. Pause the video and count to convince yourself that there is indeed 11 bright spots, and therefore measuring 10 wavelengths. Now, 10 wavelengths is going to span across a distance of 28 centimeters. How long must a wavelength be? Even better, what is the wavelength in meters? Pause the video to work out the wavelength in meters. Great, you should now have measured the wavelength to be 0.028 meters. We will now measure the frequency of the wave by counting how many waves have passed through the pencil in 5 seconds on the stop clock. A countdown will play shortly, and you are going to count how many waves have passed through the pencil. I will pause the video when you should stop counting. Ready? How many waves have you counted? I have counted 82 waves. Now remember that frequency means the number of waves passing through a point per second. What would the frequency be if 82 waves passed through in 5 seconds? Once you have worked out the frequency, you can now also calculate the wave speed using the equation shown here. And when you're done, compare your answer to the one you have calculated earlier. Are they close?